Right now, this is probably the most fascinating peptide that's associated with fat loss, but also with glucose metabolism and insulin resistance. And full disclosure here, okay, when we talk about peptides, I'm talking about going to your doctor and consulting with them. I'm also talking about rodent model research. I'm talking about some human model research, but this video is really for entertainment purposes only. So when you look at peptides, we have to take it with a grain of salt. Lots of interesting emerging rodent model research, a fair bit of human model research, but the clinicals are lacking. And that's just what you have to accept when you look at some of these peptides. Some of them are newer. However, when we look at a lot of these peptides, there are also things that are produced by the body. So today I'm talking about a peptide known as MOTS-c, which has really promising evidence. And it seems to be, looking at these safety profiles of it, one of the ones that is probably most realistic because it's produced by our mitochondria when we exercise anyway. So in an interesting way, it's like a concentrated exercise mimetic. So we'll talk about it from two perspectives in this video. We'll talk about it from the perspective of, hey, this is produced when you exercise anyway. So huge benefit there by naturally releasing this peptide when you exercise. And if you want to consult your doctor or physician, then go right ahead and talk about MOTS-c as a peptide. And after this video, I put a link down below to check out my friend's book. Okay, it's called The Longevity Nutrient, and it's written by Dr. Stephanie Venn Watson and Eric Venn Watson. And it is a really solid book that talks about various deficiencies that contribute to poorer longevity, poorer health span, but it's a really fascinating book. And I also put a link down below for their interesting product that they created in partnership with the Navy, which is quite interesting, called Fatty 15, that helps out cellular integrity. So essentially it makes it so that a cell doesn't become super rigid, but also doesn't become so flexible that it's susceptible to oxidative stress. It's hard to describe in like a quick 15, 20 seconds, but I'd recommend that you check out that book. So that book is down below. I linked for it down below in the top line of the description. And I also linked to Fatty 15, which is a C15 replacement supplement for one of the worst deficiencies that we're seeing in the world right now, and the first clinical deficiency discovered in 75 years. So anyhow, that link down below also gets you a discount on the product, but it's all down below in the top line of the description. Now let's talk about the peptide. So MOTS-c is a peptide that is encoded by the mitochondrial DNA. So it's encoded by the mitochondria. And again, it's likely as a response to exercise, but I'm just gonna get right into the nitty-gritty of it. We're gonna talk about a Nature Communications study that had a human element to it and a rodent model element to it. We'll bounce back and forth and come back to it a few times in this video. But first off, let's talk about the human side. What they did is they wanted to look at the exercise-related impact on MOTS-c first. So they wanted to see like the natural production of it. So they took sedentary people and they had them do light exercise for about 4 hours. And prior to and post-exercise, they actually tested and did a muscle biopsy and they looked at their MOTS-c levels. What they found is that after exercise, there was a 12-fold increase in MOTS-c. So it was very evident that MOTS-c had a pretty big, or was a response of exercise, which is pretty cool. Now, it's more interesting when you start thinking about MOTS-c in like a supplemental or exogenous form, because it's like, okay, this is effects of exercise potentially. But now we pivot over to some animal data because it helps us understand mechanisms more and understand like from an exogenous perspective. So this study was published in Aging Cell, okay, and they gave mice a low or a high dose of MOTS-c a few times per week, and they did various tests with them. In this particular case, they put them on a very high-fat diet to try to induce not only insulin resistance, but just some metabolic distress and dysfunction. So very high saturated fat, high calorie diet. They put them on this, and they found that when they were taking MOTS-c, it blocked the negative effects, so they did not develop the insulin resistance, compared to the control mice did develop the insulin resistance. Now, why is this happening? I mean, in short, you're boosting mitochondrial health. If the mitochondria can function better, then you can ultimately deal with glucose and you can deal with fuel better, thereby resulting in less potential insulin resistance. But they also noticed that there was a significant amount of weight loss. They noticed there was a decrease in appetite, and overall glucose management was significantly better. Now, what was the really wild thing here, and this is super captivating, is that the effects were really good when they were on like a bad diet, like it mitigated the effects of a bad diet, but the results were really, really, really good when they were eating a normal or a good diet. This is a little bit unusual because usually peptides or things like that, they help offset these negative things and sometimes become more effective the worse a diet is. But because we're dealing with the mitochondria, the more exercise, the more good diet, the mitochondria is already thriving. So then MOTS-c was like getting the effect even more. So it actually works really, really well when the diet is good and when potentially exercise is there. What they found is that MOTS-c improved insulin resistance much more so in the muscle cells than anywhere else in the body on these mice, indicating that it's definitely, or seems to be, definitely related to exercise. Because you can get more insulin sensitive in the liver, in other organs, but in this case, it was predominantly muscle related. Probably one of the most fascinating things of this study, though, is they found that older mice that were exhibiting insulin resistance signs, once MOTS-c was administered, they actually started to resemble the insulin sensitivity of younger mice. So in a way, it was making their mitochondria sort of younger, for lack of a better term. Lastly, there were massive reductions in inflammatory cytokines, reductions in interleukin-6, reductions in tumor necrosis factor alpha, which could have been downstream of the fact the mitochondria is functioning better and able to use fuel better, thereby resulting in less inflammatory response. How is this happening? And this is important to know how it's happening, because if you're going to even investigate this or talk to someone about it, you should know what's going on. It is speculated, but pretty flushed out, that MOTS-c is changing what's called the folate cycle. What happens here is then there is something called purine. This disrupts purine synthesis, which now we get into a world that you probably know more about, therefore increases what's called AMPK. So it's essentially making the body think that it's in a little bit of a deficit and that it's exercising. Right? By increasing AMPK, that increases when you exercise, that increases when you're in a deficit. That's sort of your energy sensor within the body, thereby improving mitochondrial function, mitochondrial density, and thereby just getting you almost the benefits of exercise. So when we talk about exercise, if one were to, or a mouse were to utilize MOTS-c for exercise performance or for muscle building, what would happen? Well, the good news is we've got some data here too, but again, don't 100% take my word for it. This is rodent model research, but that's where we start. This Nature Communications study took a look at MOTS-c, and it found that mice ended up having an increase in a couple of things with exercise. For one, their motor coordination improved dramatically. This is interesting. That's actually really interesting to me. Like, I would love to be able to have more coordination and be able to do more athletic things. So that's fascinating. But they also saw increases in their overall performance too. They put them on a treadmill, and they did treadmill tests with them. And they found, compared to 7 to 10 days of MOTS-c supplementation at various dosages, high dosages of MOTS-c improved their treadmill overall performance dramatically at 10 days, but not at 7 days. What that tells us is that it takes a little time to build up. It's not like something you just were to take and it were to magically fix things, right? So it's like in conjunction with exercise, massive improvements. But here's where it gets really fascinating. They had these mice go on the treadmill and they had them run. And then they would increase the intensity as much as they can until the mice were sprinting. 100% of the mice that were given the MOTS-c peptide were able to reach the maximum effort, full sprint. Only 16.6% of the mice that didn't get the MOTS-c peptide were able to hit that maximum sprint. 100% hit maximum effort. Only 16% hit maximum effort if they didn't have MOTS-c, showing time to exhaustion, overall output and performance improved. Why? Simply put, it improved the mitochondrial efficiency, so the mitochondria were able to produce more energy, utilize fuel better, thereby utilize fat better and burn fat better, utilize glucose better, and thereby create more anaerobic power and output, and they were able to perform with less time to exhaustion, or more time to exhaustion, rather. American Journal of Endocrinology and Metabolism published something really fascinating with muscle building, though. Again, rodents, but what they found is that when MOTS-c was administered, there was a 40% reduction in what's called myostatin. Myostatin is what stops muscle from growing. Like, it is like sort of what is put in place to prevent muscles from getting too large. And I'm not saying we're getting abnormally, like genetically out of control, but when you exercise and you stress your mitochondria, there is going to be a bump in myostatin or a decrease in myostatin to accommodate for the growth because the mitochondria is getting stronger and the muscle is getting bigger. So myostatin isn't like fixed from the time that you're born. So don't get me wrong, we're not artificially changing myostatin, but we're influencing how much a muscle can grow in response to exercise. This is also done on mice that were fed a really poor diet. When they were fed a poor diet, it was blocking the obesity-induced atrophy. So normally if you have a lot of fat on you, it actually contributes to atrophy, breaking down muscle. MOTS-c actually blocked that. It protected the muscle. This differs from things like follistatin, which are extremely expensive gene therapies that work to inhibit myostatin, but they don't block against the obesity-related atrophy or sarcopenia per se. They only improve you with building muscle. At least that's what the research shows. We're seeing with MOTS-c, because it's more natural in the sense that like the body's producing this when you exercise, it's a more realistic way to prevent atrophy. And I'm fascinated by this. This is the kind of thing we should be looking at for muscle building. Like we look at, okay, we're basically just enhancing the body's natural outcomes from exercise, getting us a more, I don't want to say natural muscle building. If you're using a peptide, you're not really natural, but you are playing upon your body's natural systems more, which is pretty cool. I should probably mention some of the most fascinating stuff though, and that's the longevity aspect. And you might want to click off now because you're like, okay, I found the performance stuff. No, I think you still want to hear this because muscle plays a big role in longevity, and this is probably the most fascinating thing I've ever seen from a peptide perspective in regards to longevity. There was a study published in the journal Aging First that found that people that were between 70 and 80 years old had about a 21% drop in naturally occurring MOTS-c levels in response to exercise compared to people that were 18 to 30. So as we get older, we produce less MOTS-c. Kind of no surprise, like we're not pushing as hard, our muscle's a little bit more decrepit, you know, the whole deal. But if we look at a study that's published in Aging Cell, we understand something more about MOTS-c. I'm going to read a quote from this study. We suggest that the M.1382AC polymorphism located in the MOTS-c encoding the mitochondrial DNA, which is specific to the Northeast Asian population, may be the putative mechanism explaining high longevity of Japanese people. Essentially, what happens with MOTS-c actually is what is genetically going on with Japanese people to live longer. I find that so fascinating. Like you're seeing like Japanese people basically have the exercise peptide circulating because of a genetic polymorphism. Does that mean that by taking a MOTS-c peptide, you emulate this? Some of the rodent model research kind of looks like that. As a matter of fact, check out this study. Another Nature Communications study looking at late life administration of MOTS-c 3 times per week in mice found that there was a significant, and I mean significant, increase in health span. Not lifespan, but health span. Their quality of life at an older age, which is what we've noticed with Japanese cultures as well. They have a better health span. There was a modest 7% increase in lifespan with mice, but a lot of times when you look at lifespan increases in mice, it does not directly correlate with humans. Okay, it could be 7% in mice, it could be 0.5% in humans. Hard to tell with actual lifespan because the overall life of a mouse is different. But when you look at health span, it's a lot more equatable. And it was such a dramatic change that we could really understand it. Probably has to do with, once again, insulin resistance, metabolomics, being able to utilize fuel. So when we see this quote from these researchers showing that, hey, this is what we see with Japanese people, and they do live long, just kind of naturally, independent of a lot of things. And then this is what we see with the MOTS-c peptide. So it's like Japanese people respond better to exercise, and they have this exercise-related peptide probably circulating more. As always, keep it locked to here on my channel, and I will see you tomorrow.